I'm John Barrett, the founder and CEO of Auctus Surgical. When I first observed Dr. Diab at UCSF performing a vertebral body tethering procedure on a young girl, I realized right then and there that we had the opportunity to develop a true life-changing therapy to treat pediatric scoliosis.
The Auctus system, along with the other tethering systems, are designed to eliminate this: fusion surgery and all its associated trauma, complications, and hardware. We want to get to this. There's a young girl looking at fusion surgery. Instead, she got a tether 2 years later. She's got a straight spine and almost full motion.
I am biased because I believe in refusing to fuse.
It clearly works. We've been doing it for years, decades, really.
20% of the time, the tether breaks, that causes reoperation. We've got a different tether, a much stronger tether, and the way we affix it isn't going to create any weak points. So we don't anticipate tether breakages at all, and it's dynamic. So that's really the primary thing. You can make adjustments over time, release the tether if you want to, go back and tension if you want to more. But none of those things are available with the current system.
You're avoiding the trauma of the secondary surgery. That'll resonate with a lot of people. What if we could change the paradigm of treatment by substituting permanent fusion with a dynamic system that can gradually correct spinal pathology, allowing greater mobility for patients and an easier surgery for physicians? Our next presenter is John Barrett, and he's here to present the pitch for Auctus Surgical. Thank you, John.
I'm John Barrett, the founder and CEO of Auctus Surgical. When I first observed Dr. Diab at UCSF performing a vertebral body tethering procedure on a young girl, I realized right then and there that we had the opportunity to develop a true life-changing therapy to treat pediatric scoliosis.
The Auctus system, along with the other tethering systems, are designed to eliminate this: fusion surgery and all its associated trauma, complications, and hardware. We want to get to this. There's a young girl looking at fusion surgery. Instead, she got a tether 2 years later. She's got a straight spine and almost full motion. Auctus is going to take this to the next level with a dynamic system and a much stronger tether. Low-profile screws are placed along the vertebral bodies, along with the magnetic engine for adjustment. The tether is inserted through the screws, but only fixed at the top and the bottom, allowing for full systemic adjustment. By activating an external controller, the tether can be tensioned non-surgically over time. With a combination of tensioning and growth modulation, you get to a straight spine. And once you're there, the tether can be released to prevent overcorrection and permit full motion.
An initial report from Peter Newton actually showed about a 25-26% overcorrection rate with the tether. And similarly, we've seen about 10-15% of children overcorrect and need adjustments based on that. This is an example of a child who had a nice double tether with good results initially, but then overcorrecting across where the arrow points in the thoracolumbar junction. She ultimately needed another surgery to release this and a brace, but really the device of the Auctus would avoid this by allowing us to release tension as necessary, or in some cases maybe tension more. Really, I look forward to bringing this to the market and helping improve our outcomes in these kids.
Great video, John. Tony, can you start us off?
Absolutely. Well, first of all, I'd like to say I'm highly biased here. I am biased because I believe in refusing to fuse. So to begin with, preserving motion in the spine is an essential component of longevity, happiness, and removal of pain in one's life. The tethering direction in deformity correction, I think, is a very appealing direction. So, John, congratulations on the direction, and congratulations on the couple of changes that you're making to the tethering technology. So the first question is, how far are you along in the product development? Let's ask that first, very briefly.
Yeah, thanks, Tony. We've been iterating. We're at our last point of iteration. We're actually putting together our IDE submission. We're going to have our first pre-sub meeting soon. That's actually being done by your guys at MICRA. So that's the status, and we're going to do a couple more animal studies, and we hope to have that submission for the IDE before the end of the year. And that's going to include a trial protocol
as well as a testing package that we've already had these discussions with the FDA, so we feel pretty good about where we're going with it.
Thank you. Mike, please.
Thanks, John. I'm a big fan of treating spinal deformity without fusion. I started doing that in the development role at Medtronic years and years ago with staples and tethers and some other things.
I've seen your name in a lot of patents, Mike.
Yeah, I've got a little bit of IP sprinkled out there. Unfortunately, I don't own any of it anymore. So, and it clearly works. We've been doing it for decades, really. I even have a daughter with a friend who's had this done, and successfully. So my question, though, and I don't know the answer, and I'm not sure anyone's published it, but what's the long-term endpoint here? I mean, can you take the tether out at some point? Can you just cut it? Do you have to convert to a fusion? When I was involved, we didn't know the answer, but we knew we were doing good work.
Yeah.
You guys know what's going to happen?
Yeah, well, the goal is, of course, with our system, once you get to the point where you want to be with a straight spine, you just release the tether. So you release all tension, and now you've got full motion. And we don't envision necessarily taking anything out. Like most implants, the original intention was pedicle screws was to take them out. Well, nobody ever takes them out. So right. it's and we have a lot less hardware than an anterior fusion for sure. So there's a lot less going on here, much smaller screws. So really, the intention would be to not take anything out unless there's a problem.
Thank you, Mike. Audrey, please.
Thanks for the presentation. Looks like great technology. Tell us a little bit, for the folks who aren't so familiar with this area, what's different from similar devices? I get the motor part, and I see that
sure.
as very unique. But are there other aspects that are unique?
Well, primarily the current device that has an approval, an HD approval, is a device from Zimmer that wasn't really designed for this indication to begin with. The surgeons made it work just by doing the right thing with it. But the screws are too big. They were made for adults. Our screws are going to be much lower profile. We're trying to minimize hardware. The tether breaks 20-odd% of the time. The tether breaks. That causes reoperation. We've got a different tether, a much stronger tether, and the way we affix it isn't going to create any weak points. So we don't anticipate tether breakages at all, and it's dynamic. So that's really the primary thing. You can make adjustments over time, release the tether if you want to, go back and tension if you want to more. None of those things are available with the current system from Zimmer. It's very static. Surgeons have to kind of guess when they do surgery how much they think this child's going to grow, and tension the tether appropriately, which they don't know. And so that kind of decision doesn't need to be made with our system. You're always going to be able to adjust it and tension it the way you want.
Great. Thanks for that explanation. And are there any new materials involved, and anything special about the motor that's going to require, some kind of servicing while it's implanted?
No. Well, that's the good thing is the magnetic technology is very simple. There's no power. The magnets will always spin, and that's really the best part of this. And so the only unique material is a magnet, which is completely encased in titanium. We've already been through the whole biocompatibility sort of rundown with the FDA, so we know exactly how to justify everything, and that's not an issue.
Great, thank you.
Thank you, Audrey. What portion of patients that come see the pediatric spine surgeon, what portion do you think are eligible for this kind of procedure as opposed to a more traditional fusion? Are we talking about 10 or 15% penetration, or something closer to 50, or?
Yeah, certainly closer to 50. From an early onset scoli case, there's anywhere from 10 to 20,000 kids that are young enough, they're still growing, and those are targets for this technology. Now the AIS kids, the idiopathics that are fully grown, there's roughly 40,000 of those that get fusion surgery. And that's a market we're going to be able to address because, consider it an internal brace. We put this on, we make adjustments over time and gradually straighten the spine. And so that's an entire market that's available. But it's also early intervention. That's a big market, the 30 to 50 degree curves that aren't really being treated yet. But why go through 2 years of a brace and fusion when you can have a less invasive surgery that takes 90 minutes, you're out the next day, and that's a market we're going to be able to address when surgeons are very comfortable using this procedure.
Can you comment a little bit about what you think your anticipated pricing is going to be, and we know that hardware pricing for a multi-level case could be, up to $100,000 in just hardware. So what is?
Yeah, we're not going to be there. No, I believe we're going to be in the $25,000 to $30,000 range, which gives us a healthy margin, and that's also a dramatic decrease in cost from a fusion procedure. That's something that the folks at Shriners have collected this data, and the difference is marked in the costs of the procedures. And long term, of course, we're hoping to have no adjacent segment disease that requires surgeries like all these fusion cases bring. So it's a big difference. Zimmer is charging a lot of money for its screws, by the way. I don't want to discuss how much they're charging, but the surgeons aren't happy. Let's just say that.
Listen, you've done a great job. The video is fantastic. A picture's worth 1,000 words. A video's worth even more. So congratulations on your animation. Thank you, John, and thank you, Auctus. So now let's turn to the audience and ask the audience what you think. From what you've heard, is this a winner and a future game changer, or do they need to go back to the drawing board? Fantastic. Well, that should be really encouraging to you, John, because almost 80% think you're a game changer and you can change the standard of care. So fantastic. Congratulations. So let me just for a moment now go back around the horn once more time to see if there's any additional challenges that our panelists would like to bring to your attention. And again, start with Tony.
I don't have any challenges. I'm very encouraged by this direction. And I would say, for all the no's that you may get and O's, turn them into yeses, because this is a technology that needs to advance. And I really support your direction. Let's come talk to me.
Great. Thanks, Phil.
Fantastic. Mike?
I do have one technical question. It's not a comment, I guess, but you're holding the tether at the ends. Do you have the option to hold it in the middle or add a few fixation points along the way?
We're looking at what you're saying. Let's just say that.
I'm rooting for you.
Well, I'm curious about the IP and what your patent status is.
Yeah. Well, we've gotten some very recent good news, and about a month ago, we got a notice of allowance on our primary patent, which covers all of the technology that we're doing, basically. So it's roughly 40 design claims and 10 method claims. So that was a win for us, and we expect that patent issued here in the next month or so.
Well, congratulations.
It was a battle to get there. Yeah. Thanks.
Nice work, John. I agree with our panel, and I think as you pitch this, so to speak, around, I think one point to make sure that you highlight is how you're able to control and prevent overcorrection, right? Because then you're not only avoiding the trauma of the initial surgery, but if you can avoid the overcorrection, you're avoiding the trauma of the secondary surgery. That'll resonate with a lot of people.
Thanks, Scott.
Of course. So really very interesting. If anyone wants to contact John or Auctus Surgical directly, here's the information that you'll need, and we can all attest that you can find them on the internet. John, thank you very much again. Thank you.